In a generator installation that includes a 200 amp manual transfer switch with an off position and a 50 amp twist lock recessed plug to feed the transfer switch, the overcurrent device within the generator may not provide sufficient protection for the entire system. Several factors contribute to this determination. The primary concern revolves around the potential for exceeding the ampacity of the 50 amp twist lock plug and the associated wiring. While the generator may have an overcurrent device, such as a circuit breaker, it is essential to verify whether its rating aligns with the weakest link in the circuit, which, in this case, is the 50 amp twist lock plug. If the generator's overcurrent device is rated significantly higher than 50 amps, it may not trip quickly enough to prevent damage or a fire hazard should an overload occur on the load side of the transfer switch. For example, if the generator's breaker is rated at 70 amps, then it will not protect the 50 amp cord supplying power to the transfer switch. The 2017 National Electrical Code, or NEC, provides guidelines for overcurrent protection to ensure electrical system safety. According to NEC articles related to overcurrent protection, the conductor supplying power to a load must be protected against overcurrent in accordance with their ampacity. This means that the overcurrent protection device must be sized appropriately to protect the wiring and equipment connected to it. In this scenario, the 50 amp twist lock plug and its associated wiring are only rated to carry a maximum of 50 amps continuously. If the generator's overcurrent device is rated higher, it creates a potential hazard. Secondly, the manual transfer switch itself plays a crucial role in the safety of the generator installation. A 200 amp transfer switch is designed to handle a large amount of current, but it is only as safe as the weakest component in the circuit. If the 50 amp twist lock plug is used to feed the transfer switch, it becomes the limiting factor. If the generator were to supply more than 50 amps through the twist lock plug, it could overheat, melt, or even cause a fire. Thirdly, the location of the overcurrent device is another important consideration. The ideal scenario is to have overcurrent protection at the point where the conductor receives its supply. In this case, the overcurrent device within the generator is intended to protect the generator itself from overloads. However, it may not effectively protect the wiring and equipment downstream, particularly the 50 amp twist lock plug and the wiring between the generator and the transfer switch. To ensure adequate protection, it might be necessary to install an additional overcurrent device closer to the twist lock plug. This supplemental overcurrent protection device should be rated at 50 amps or less to protect the wiring and the plug from overloads. The goal is to have the overcurrent device stripped before the wiring or the plug is damaged. Fourthly, voltage drop must be considered. When a generator is connected to a load through a transfer switch, voltage drop can occur due to the resistance of the wiring. If the wiring is undersized or the distance between the generator and the transfer switch is too long, the voltage of the load may be significantly lower than the generator's output voltage. This can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it is essential to use appropriately sized wiring and keep the distance between the generator and the transfer switch as short as possible. The NEC provides guidelines for calculating voltage drop and selecting the correct wire size to maintain voltage within acceptable limits. Fifthly, grounding and bonding are critical aspects of generator installations. Proper grounding ensures that the generator and the connected equipment are at the same electrical potential, which helps to prevent electrical shock hazards. Bonding refers to the connection of metal parts to create a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device in the event of a ground fault. The NEC specifies the requirements for grounding and bonding generator installations to ensure safety. Sixthly, labeling is essential for a safe generator installation. The transfer switch and the generator should be clearly labeled to indicate their purpose and operating instructions. The labeling should also include information about the maximum current that can be supplied through the twist lock plug. This helps to prevent accidental overloads and ensures that users are aware of the limitations of the system. Seventhly, regular inspections and maintenance are necessary to ensure the continued safety of the generator installation. The wiring, connections, and overcurrent protection devices should be inspected periodically for signs of wear, damage, or corrosion. Any issue should be addressed promptly to prevent potential hazards. Maintenance tasks such as cleaning the generator and checking the oil level should also be performed regularly. Eighthly, compliance with local codes and regulations is mandatory. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations that apply to generator installations. It is essential to consult with a qualified electrician and obtain the necessary permits before installing a generator to ensure compliance with all applicable codes and regulations. Ninthly, consider the specific application of the generator. Is it intended for standby power during outages, or is it used for portable power on job sites? The application will influence the specific requirements for overcurrent protection and other safety features. For example, a generator used for standby power may require a different type of transfer switch and overcurrent protection than a portable generator used on a construction site. Tenthly, it is critical to use appropriately rated components. All electrical components, including the twist lock plug, wiring, transfer switch, and overcurrent protection devices, must be rated for the voltage and current levels of the generator system. Using undersized or improperly rated components can create a significant safety hazard. In summary, the overcurrent device in the generator may not be sufficient for a 200 amp manual transfer switch setup with a 50 amp twist lock plug. It is essential to assess the entire system, including the wiring, the twist lock plug, and the transfer switch, to ensure that all components are adequately protected against overcurrent. Compliance with the NEC local codes and regulations is also crucial to ensure the safety of the generator installation. Consulting with a qualified electrician is highly recommended to ensure that the generator system is installed and maintained in accordance with all applicable standards. Always prioritize safety when working with electrical systems. The potential risks associated with improper generator installations can be significant, including electrical shock, fire hazards, and equipment damage. By following best practices and adhering to safety guidelines, you can minimize these risks and ensure a safe and reliable power supply. Furthermore, consider the load requirements connected to the transfer switch. If the connected loads have a combined amperage greater than 50 amps, the 50 amp twist lock plug and its associated wiring will be overloaded, regardless of the generator's overcurrent protection. In this case, it would be necessary to either reduce the load or upgrade the twist lock plug and wiring to a higher amperage rating. An additional safety measure is to use a ground fault circuit interrupter, or GFCI, on the generator or the transfer switch. A GFCI is designed to detect ground faults and quickly interrupt the circuit to prevent electrical shock. This is particularly important in wet or damp environments, where the risk of electrical shock is higher. Review the generator's specifications and documentation carefully. The manufacturer's instructions will provide valuable information about the generator's capabilities and limitations, including the recommended overcurrent protection. It is important to follow these instructions to ensure safe and reliable operation. Keep in mind that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for specific recommendations regarding your generator installation. Remember to perform regular testing of the generator system, including the transfer switch and the overcurrent protection devices. This will help to identify any potential problems before they become serious hazards. Testing should be performed under the supervision of a qualified electrician. When selecting a generator, consider its output power rating and ensure that it is sufficient to meet the needs of the connected loads. An undersized generator can be overloaded, which can damage the generator and create a safety hazard. An oversized generator, on the other hand, may be less efficient and more expensive to operate. Use appropriately sized extension cords and power strips with the generator. Extension cords and power strips should be rated for the amperage and voltage of the connected devices. Avoid using multiple extension cords in series, as this can increase the risk of voltage drop and overheating. Protect the generator from the elements such as rain, snow, and extreme temperatures. Exposure to the elements can damage the generator and reduce its lifespan. Use a generator enclosure or cover to protect the generator from the weather. Store fuel safely and in accordance with local regulations. Gasoline and other fuels are flammable and can pose a fire hazard if not stored properly. Store fuel in approved containers in a well-ventilated area away from ignition sources. Never refuel the generator while it is running or hot. Turn off the generator and allow it to cool down completely before refueling. Use a funnel to avoid spills. Clean up any spills immediately. Never operate the generator indoors or in an enclosed space. Generators produce carbon monoxide, a colorless and odorless gas that can be deadly. Always operate the generator outdoors in a well-ventilated area. Install a carbon monoxide detector in your home to alert you to the presence of carbon monoxide. Be aware of the noise generated by the generator and take steps to minimize it. Generators can be noisy, which can be disruptive to neighbors. Use a generator enclosure or place the generator in a location where the noise will not disturb others. Do not modify the generator or its components without consulting with a qualified electrician. Modifications can void the warranty and create a safety hazard. If you have any questions or concerns about your generator installation, consult with a qualified electrician. It is always best to err on the side of caution when working with electricity. The use of a 50-amp twist lock plug is not sufficient, and an electrician should be consulted to determine the proper size components needed to make the proper connection and adjustments with the generator installation.